So one of the most important lessons we are going to do all year is the unit circle. Today even, my calculus class is taking a quiz, and they have to know these values in order to successfully finish the quiz. So they don't go away. They are going to follow us for the rest of the school year. And then if you take any higher level math, they would expect you to know the unit circle. So this is just an introduction to it. We are going to do the more formal lesson on Monday, but I did just want you to get used to it because the paper that you have will be a memory quiz that we will be taking probably on Tuesday or Wednesday of next week. So there's lots of patterns and ways that you can memorize the unit circle between now and Tuesday or Wednesday. And one of the ways that has always helped many of my students is the colors. So that's why we're doing that. So the first thing I want you to do is let's fill in this top area right here. Now, yesterday, or whenever we had done 7-3, the 7-3 part A, we had learned that the cosine was x over r, and that the sine was y over r. But the unit circle is called a unit circle because the radius is exactly 1 unit long. So the circle that you see here has an exact radius of 1. And what this circle does is this circle allows us to know the value of our trig functions without a calculator. So what's interesting about this circle, well, at least to mathematicians, not necessarily to you, but maybe, is that the x value on our circle is exactly the cosine of theta, because before it was x over r, but r is 1, so x over 1, just x. The y value on the circle is exactly the sine of theta, because it will always be the opposite of the triangle that touches that point. And the tangent is y over x, or it becomes sine over cosine. So those facts that are up in that left corner, you have to know by heart. You have to know that the x value gives you the cosine, the y value gives you the sine, and the tangent is y over x, or sine over cosine. Now those values will help us. Again, our goal with the use of the unit circle is for us to be able to use the unit circle to find some exact values of our trig functions without a calculator. So if we memorize the unit circle, we get lots and lots of values for free. Okay, so the first thing we're going to do, if you could highlight your x and y axis, I did it in a yellow color, so if you have a light color, you want to highlight your x and y axis yellow, or color it in yellow, that would be greatly appreciated. If you hit those angle measures, if you hit the yellow lines, we call those quadrantal angles. We hit the quadrants. We landed on the quadrants. Those quadrantal angles are 0 degrees, 90 degrees, 180 degrees. Let's put this right by that little degree mark, 270 degrees, and let's add a little one here, 360 degrees. So if we count by 90s, here's our 0 mark, 90, 180, 270, 360. Now let's put on there what we know about radians. 0 degrees is 0 radians. Now let's go over to 180. 180 we know is exactly pi. So if you know that, you can always do if you know the degrees, you tack on a pi and put it over 180 and then reduce it. So remember, degrees, tack on a pi over 180 and reduce will always give you radians. Okay, degrees, tack on a pi, put it over 180, and reduce will always give you radians. But I'm going to show you some nicer ways to memorize the radian measure without having to do that every single time, okay? So if we cut 180 in half, we get 90. So if we cut pi in half, we get pi, half of a pi. We write that as pi over 2. So the radians at 180 are pi, the radians at 90 are pi over 2, the radians at 0 are 0. Okay. Now let's do 270 for a minute. Can anybody tell me how many times 90 goes into 270? 3 times, right? So this is 1/2. This is 2 halves. So that one, guess what? Will be 3 of those, 3 halves. So this one is 3 pi over 2. 3 halves. And then remember, this is 1/2 of a pi, 2 halves, 3 halves. That's 4 halves. Or one loop around our circle is always 2 pi radians. One rotation, one loop around, 360 degrees, is always 2 pi. Okay, so now we've done the radians there. Now let's talk about the points at those locations. So if I go over here and I think about where I hit that point right there, that point right there is touching the circle that had a radius 1. So this is the point 1, 0, okay? Because I went 1 to the left, or 1 to the right, I'm sorry, and up nothing. So look at 180. Wouldn't that be negative 1, 0? And let's do 90. I went nothing left and right, but up 1. And 270 is kind of the negative version of that. And so we get zeros or ones for all the quadrantal angles. Zeros, ones, and negative ones. Okay. Now, here's how you use the unit circle. If I said to you, what is the sign of 2 pi? Well, you just have to know that at 2 pi, I hit the point 1, 0. The sign is the y value, 0. If you put it into the calculator right now, the sign of 2 pi in radian measure, and you hit the equal button, you're getting 0. If you hit the cosine of 2 pi, you're getting 1. The x value at that location is the cosine of that angle measure. The y value is the sine. Okay, let's do this one. If I said, what is the cosine of 90? 0. What is the sine of 90? 1. I don't have to build a triangle. I don't have to enter into a calculator. The unit circle gives me that information. The cosine at that location is, the x at that location is your cosine. The y at that location is your sine. It's as simple as that. And that's really great because then we can build all the other things. Okay, so those are our quadrantal angles, zeros and ones. Okay, now if you could make our widest x, if you could make that kind of a reddish or orange or something like that, if you could make our widest x reddish or orange, I would appreciate that. Okay, now our widest x here is representing everything that is 30 degrees away from the x-axis. So that reference angle, we're going to call it a reference angle. In reference to the x-axis, we're 30 degrees away, okay? So what does that mean? Well, that means this spot is 30 degrees. I went 30 degrees up. Okay. Now, if I'm 30 degrees away from hitting 180, that means that's 150. If I'm 30 degrees after 180, that's 210. And if I'm 30 degrees away from hitting that 360 mark, I have gone 330 degrees to get to that spot. Okay, so let's discuss this. These all have reference of 30. We are 30 degrees away from the x-axis. This is 30 degrees. This is 30 from 180, so 150. This is 30 after 180, 210. This is 30 from hitting 360, 330. Okay. Now, we know for radian measure, we could tack on a pi and put it over 180, right? So it's always referencing 180. How many times does the number 30 go into 180? How many times does 30 go into 180? 6. So this ends up being pi over 6. So you just have to reference this back to 180, okay? Now, once we know the reference angle, in this case, 30 is pi over 6, how many 30s are in 150? 5. So wouldn't I need 5 pi over 6s to get to that location? 5 30s is making 150. So this is 5 pi over 6. Now, do the same thing with all the reference angles of 30, and it will work every time. As long as you know that 30 is pi over 6, just how many 30s I got? How many 30s are in 210? How many 30s? 7 are. So that would be 7 pi over 6. Now you could do the thing 210 pi over 180, but it reduces to 7 pi over 6. How many times does 330 go in, or I'm sorry, how many times does 30 go into 330? 11. That's 11 pi over 6. So all of our red angle measures are related back to 30. They're referencing 30. So if you know that 30 is pi over 6, this is 5 pi over 6s, 7 pi over 6s, and 11 pi over 6s. So that's going to work every single time. Now let's talk about the point. All of those, and I'm sorry, I'm not drawing them very good. Let me try again. All of those, if we were to do SOHCAHTOA, do you see how they all have exactly the same triangle? Just flipped around, same exact triangle. That means it's opposite and adjacent and hypotenuse are always going to be related to one another. So if we know this one, we know what it is. Now tell me this, in my triangle, this is the adjacent, that's my x. This is the opposite, that's my y. Which one's bigger? Is the x longer or is the y longer? The x is a lot longer, isn't it? So that's one way we can remember, and this is just values you got to know, that the x value is bigger than the y value, and you're always going to use the point square root of 3 over 2, 1/2. Now that can come from special triangles. The one across from the 30 is always 1/2 of your hypotenuse. We know the hypotenuse is 1, half of 1 is a half. I don't know how you want to remember that, but I'll show you some other tricks as well. But the point on the unit circle related to 30 is square root of 3 over 2, 1/2. Those are the exact values. So if I said, hey, what is the cosine of 30 degrees? You can immediately say square root of 3 over 2. If you put cosine of 30 in your calculator, you get a decimal. I believe it's something like 0.8 something. Square root of 3 over 2 gives you that exact value. Okay. If I said, hey, what's the sine of 30? Guess what? It's a half. So now we just learned about the sine and cosine of 30 without a calculator. Now we're going to put those same values everywhere. But remember, here, the x and the y are both positive. So that means your sine and cosine are both positive in that region. So that means the positive stuff are the sine, the cosine, and the tangent. So now let's go to 150. Now let's go to 150. Same point, square root of 3 over 2, 1/2. But this time our x went in the negative direction. So this time our x is negative and our y is positive. So that means that our sine is positive, but our cosine is negative. So if I said, what is the cosine of 5 pi over 6? Oh, it's that one. Cosine is negative square root of 3 over 2. If I said, what is the exact value of the sine of 150? 1/2. You don't have to use a calculator. Now we're going to use those same values down here. Square root of 3 over 2, 1/2. Put them down. Square root of 3 over 2, 1/2. But in this quadrant, they're both negative. because I went to the left and down. So in this, both our x is negative, so our cosine is negative, and our y is negative. But that actually makes our y over x positive. So our tangent is positive. Okay. So it's still square root of 3 over 2 1/2, except they're both negative. Now let's jump over to 330 for a moment. 330 still uses square root of 3 over 2 1/2. Which one's negative this time in the fourth quadrant? Just the sine, which makes the tangent. So here, the y is negative, which makes the tangent negative, but the cosine is positive. Okay, we're moving right along. Yeah, okay, sorry. Thank you. Yeah. Yep. Let me show you this whole thing. Okay, so, you know, and I'll post this video because you're going to want to do it and build it again and again until you get it in there. Okay, so those are the 30s. So our 30s are always related to square root of 3 over 2, and their denominators in the radians are always over 6. The denominator is always something over 6. So that's why 150 is over 6, 210 is over 6, 330 is 11 pi over 6. Okay, so now we're going to do the green ones. So if you want to do, that's the exact middle x, the perfect x. Please make the perfect x here green. So I'm talking the smack dab in the middle one. Could you make that one green if you want, like a greenish color? So that's the exact middle, exact, perfect, symmetric, beautiful x. Okay. So that one there cuts 90 perfectly in half. That's why it's 45. So you're just counting by 45s. You're just counting by 45s. So, you know, 45, 90, we're going 45 again. So I just add 45, I get 135. 45 more is 180. And the next 45 is 225. Add another 45, it gets you to 270. Add another 45, 270 plus 45 is 315. Another check that you're right. These should be 15 apart. Are those 15 apart? Sure. 15 apart, 15 apart, 15 apart. Those are always 15 apart. Okay. Let's talk about the radian measure. If you cut a pi over 2 into, well, let's relate it to 180. Wouldn't it take 4 slices? 1, 2, 3, 4 slices of 45 to get to 180. What's half of a half? A fourth. So this is pi over 4. 45 goes into 180 4 times. You can count wedges for 45s. This is 1 pi over 4, 2 pi over 4s. This is 3 pi over 4s. Pi over 4s is not a great way, you know, they're weird. But 135 is divisible by 45. 145 divided by 45 is 3. So that's where 3 pi over 4 comes from. This bottom one here is 5 pi over 4. This one here is 7 pi over 4. Okay. You might recall back in geometry class, A 45-45 right triangle is an isosceles triangle. The two legs are always the same value. That is one way to remember that the point at 45 is square root of 2 over 2. Square root of 2 over 2. They match. Okay. So this one is negative square root of 2 over 2. Square root of 2 over 2. This one is negative square root of 2 over 2, negative square root of 2 over 2. This one is positive square root of 2 over 2, negative square root of 2 over 2. So we use square root of 2 over 2 at all of the 45s. Our first quadrant's always positive, positive. Second quadrant's always negative, positive. Third quadrant's always negative, negative. Fourth quadrant's always positive, negative. So that's your 45s. So anytime what's great about the 45s is if they ask you what the sine or the cosine is of 45, it's always square root of 2 over 2, sometimes positive and sometimes negative. So that's the great part about those. Okay. So now I've moved on to my blue lines. So if you have blue that you would like to use, some kind of blue or purple or something, I'm talking about the blue lines here, and that is 60 degrees. Now, all the blue lines are 60 degrees away from the x-axis. They have a reference of 60. If we build this triangle, you might recognize that triangle because we actually already used that triangle one time. It is just the 30, 60, 90 triangle flipped on its head. It becomes a 60, 30, 90 triangle. Same idea. So these values just flip around. So instead of square root of 3 over 2, 1/2, think about our triangle. This time, what's bigger, the x or the y? This time the y is bigger, right? So that's why our point, instead of square root of 3 over 2, 1/2, we need the square root of 3 over 2 to be second. So it just turns. 30 and 60 are always complements of one another. The sine of one will be the cosine of the other. Complements always do that. The sine of one will always be the cosine of the other. Okay. Let's do our reference. These are always 15 away. These are always 15 away. You can reference it that way. 60 degrees away from hitting 180 is 120. 60 degrees away from here is 120. I don't care how you do it. It's 120. Down here, if I go 60 degrees more after 180, that's 240. 60 more away is 300. Or 60 away from here is 300. So those are the 60. 60, 120, 240, 300. Let's do the radian measure. How many times does 60 go into 180? How many times does 60 go into 180? What do you think? 60 goes into 180, how many times? 3 times. So this one is pi over 3. That one is pi over 3. So look at the thing that we have here. All of our 30s had a 6 denominator. All of our 45s had a 4 denominator. All of our 60s had a 3 denominator. And all of our quadrantals were either half pies or full pies. So the denominators should get smaller as they go up. So pi over 6, pi over 4, pi over 3, pi over 2. So that's a pattern that can help you. So let's do this. 60 goes into 120. How many times? 60 goes into 120. How many times? 2 times. So that's 2 pi over 3. Let's do 240. 60 goes into 240. How many times? 60 goes 4 times. So that's 4 pi over 3. 60 goes into 300. How many times? 5. So that's 5 pi over 3. Let's put on our points. We're going to use 1/2 square root of 3 over 2 every time. change the sign appropriately depending on what quadrant we're in. In the second quadrant, the x is the only negative one. The third quadrant, both are negative. And the fourth quadrant, just the y is negative. But we use the same 1/2 square root of 3/2 because the same size triangle lands in all 4 places. So remember, the x value on the unit circle gives you the cosine. The y value on this unit circle gives you the sine of that location. If you want the tangent, do y over x. Once you know the 3 originals, just flip them upside down, use the reciprocal, and then you have the secant, cosecant, and cotangent. Okay. Now you're going to have this memorized. This isn't going away. You will have to use it the rest of the school year. It is important that you know it. I'm thinking most likely that we will have this quiz. I'm going to practically give you this exact same paper, and it will most likely be Tuesday or Wednesday. So you have between now and then. We're going to do it one more time together on Monday, so we're not done building it together. We'll do it one more time. Could you please flip over your paper? There's some information on the back that I want you to do. So our 6 trig functions, this is what I'm looking for. First, let's do sine, cosine, and tangent. I need 2 things. First, for sine, I need the fact that it is opposite over hypotenuse. But I also want you to tell me that that's our y. So opposite over hypotenuse, and it's our y value. Cosine, I want you to tell me it's adjacent over hypotenuse. It's our x. Tangent, I want you to tell me that it is opposite over adjacent, or y over x. So that's what you need to have memorized about the sine, the cosine, and the tangent. Now, I will keep them in this exact order because I want you to always get in the habit of relating them in this order, so then you always kind of feel that they're going to go together. So that's why I have put cosecant, secant, and cotangent the way that I have, because I want you to memorize that they go together. Cosecant then is hypotenuse over opposite, or the reciprocal of y. So just you can just put 1 over y. Secant is hypotenuse over adjacent. It is the flip of our cosine, so it's 1 over x. Cotangent is adjacent over opposite, or x over y. So on the quiz, you will be given those 6 trig functions that you need to tell me those really 12 things, okay? So plan to memorize these. I have given you it on paper. You have a digital version, okay? So there you go. There is some facts. So we still have a little bit of time left. So for the remainder of your class time, please work on the homeworks that are due, and I'll take any questions that you have about those.
When are they due?